Good morning, dear students. I am Ramdas. I welcome you to my channel Maths from Basics for You. So, this is my class number 12. Earlier to this, I have taught you sum rule, product rule. So, I have to do bit on extension of product rule and quotient rule. So, I'll take that in the next class. So, prior to that, I have been told by some of our students to take some of the subjects, like some of the chapters along with differentiation. So I thought the best way is to see that subjects what I take, the chapters what I take should be common to 10th standard, diploma, PUC as well as engineering. So today I am going to teach you what is a binomial theorem. A polynomial of the sum or difference of the two terms is called a binomial. For instance, now supposing I take a to the power of 6. Can we call this as a binomial? No, it cannot be, because as the definition says, a polynomial of the sum or difference of two terms is called a binomial. So now a to the power of 6 is not a binomial. Let us take another example. A plus b plus c. Can we call this a binomial? No, because it does not contain two terms, but it contains three terms. Say if it is single or triple, more than two terms, it cannot be a binomial. So binomial is nothing but a polynomial of the sum or difference of two terms is known as binomial. So once again, let us a binomial is what? A polynomial of the sum or difference of two terms is known as binomial. So this cannot be binomial. Let us take an example of a plus b. Is it a binomial? Of course it's a binomial, because it contains two terms, right? I write this a to the power of 0. Anything to the power of 0 is 1. So though a polynomial of the two terms, that is, it's a sum of two terms, it's a binomial to the degree 0 is 1. Let us take another example. A plus b to the power of 1 to the power of 1. It is a binomial of degree 1. Now a plus b to the power of 2. So this is nothing but a plus b itself, right? A plus b. What about this? A plus b the whole square, that is a square plus 2ab plus b square, right? Now supposing the degree increases, a plus b the whole cube, you will definitely know the formula. We will say that is what? A cube plus b cube plus 3a square b plus 3a b square. This is for a plus b the whole cube. Supposing I ask you a plus b to the power of 4, a plus b to the power of 5, and so on to a plus b to the power of n. So this is possible, but what happens? You have to memorize this. It will be tedious for you to memorize this, or you have to work it out. So as the degree a to the power of 4 increases, it becomes cumbersome and tedious to expand it. So in such cases, binomial theorem helps us to find the expansion of these terms, that is a plus b to the power of 5, a plus b to the power of 6, a plus b to the power of 7, so on till a plus b to the power of n. So binomial helps you to solve such expansions. Let us say a plus b those whole square. How did you get this? That is a plus b into a plus b. If you multiply this, you get a square plus 2ab plus b square. Likewise, if you have a plus b the whole cube, so what you will do? Automatically take a plus b the whole square into a plus b. If you multiply this, that's so the bases are same, add the indices. So it becomes a plus b, this is nothing but what? A plus b. This is bases are same, that is 2 plus 1, that becomes a plus b whole cube, right? Likewise, for a to the power of 4, you can likewise similarly a plus b the whole to the power 4 equals what? You will write a plus b the whole cube into what? A plus b to the power of 1. Likewise, you bases the same, add the indices, 3 plus 1 becomes 4. So this is a plus 4, a plus b to the power of 4. You go on doing this, there is no end. So you have it becomes very cumbersome, very tedious. So in order to solve such expansions, we will use binomial theorem. Now let us know what is binomial theorem. As I said, a polynomial of the sum or difference of two terms is called a binomial. So we came to know about the definition, and I told you how to arrive at it. Now what is a plus b to the power of n? Now this is using binomial theorem. You have to expand this. So a plus b to the power of n. How do you do this? So if it is a plus b, n can be, n is nothing but a positive integer. It cannot be a negative integer, right? So n is a positive integer. So now n can take any value. For example, n, if it is 1, it becomes a plus b. If n equals 2, a plus b the whole square. If it is n equals 3, a plus b the whole cube. If n is 4, a plus b to the power of 4, and so on. So until a plus b are comfortable, you can do it. But the moment the index increases, the value of n increases, it becomes difficult for you to expand it. So in order to solve such things, we will go for binomial theorem. What it says, let us say, I will teach you this in the easiest way, so that even the weakest student in the class should be able to understand this. Now what we will do is, I will write NC naught. First begin with NC naught. I will tell you what is this later on. NC naught, I will say a to the power of 0. First I will take this a to the power of 0. Next term b to the power of n. I will take b to the power of n. Right? Later on what I will do? I will put a plus sign. So later on, so NC naught, this becomes NC1. So NC naught, NC1. See the value of this C naught, C1, C2 should increase. Then give increment to A naught. So A naught should become A1. And what will happen to B? The value of A increases, but the value of N should decrease. So B to the power of n minus 1. So next term is NC naught, NC1, automatically should get what? NC2. Now A will become A to the power of 2. And B becomes n minus 2. Next, you tell. Next term is NC naught, NC1, NC2. Now NC3, A to the power of 3 into B, sorry, A3, B to the power of n minus 3 plus so on. So this becomes what? NC n. See, NC0, NC1, NC2, NC3. What's happening here? The value of this is increasing until when? Until these values become n. So NCn into what will happen to this A? A0, A1, A2, A3, so on until A becomes n. So A will ultimately become n. And what will happen to B? B becomes n, n minus 1, n minus 2, n minus 3, n minus n, that is n minus n. So n minus n is what? 0. That is B equals to n minus n. That becomes what? B to the power of 0. So this becomes what? 0. So this is known as binomial theorem or binomial expansion. So it's very, so this depends. Next question is, so how long I should continue to add? It depends upon the value of n. Supposing a given 3, 1, that is 0, 1, 2, 3, you should stop at 3 values. That we'll see later when we are doing the problems. So this is about binomial expansion. So next what? The next thing is, I want to tell you something about factorials, because that is important here. So you should know what is factorials. Now factorials can be denoted as like this or like this. So these are notations we can use one among two, but I am comfortable, I'll use this. So you can add this. For example, I'll say 1 factorial. What does it mean? That is 1 into 1 equals to 1. This is 1 factorial. Supposing I say, or you can write or 1. So this is nothing but 1 into 1 equals to 1. This is also factorials. It's called what? Factorials. They're called factorials. You can either use this symbol or this notation or this notation. So what I'll do is, instead of this, I'll use this. So what is 2 factorials? 2 factorial is 1 into 2 is equals to 2. Multiply it. So some people, what they do, they'll say like this. Instead of that, 2 into 1 equals to 2, both ways. Now I'll take 3 factorials. 3 factorial is what? 3 into 2 into 1. This is 3 2s are 6, 6 1s are 6. 4 factorial. This is 4 into 3 into 2 into 1 equals to 4 3s are 12, 12 2s are 24, and so on. These are known as factorials. So this is, we will find its importance little later, but what you should know, factorials, how to get this. I rub this, please make a note. So 5 factorials is what? That is 5, 4, 3, 2, 1. This is 5 4s are 20, 20 into 3, 60, 60 into 2 is 120, and so on. Likewise, 1, 2, 3 factorial, n factorial. So, there are what factorials, we'll rub this. So, I can use either this notation or this. Yes, students. Now, definition of NCR. It denotes the number of combinations or selections of n different things taken at a time where n and r must be positive values. See, remember this, it denotes the number of combinations or selections of n different things taken at a time where n and r are positive values. N cannot be negative, and also Also n should be greater than or equal to r, otherwise this doesn't holds good. So remove this point is an important thing. I'll tell you how to calculate NCR. 6 C2, I'll write this. So this is nothing but where n is 6, r is 2. How to calculate this? Remember this, we know that NCR can be calculated using n factorial divided by r factorial into n minus r factorial. So this is a formula to find NCR. So here in the problem you have to calculate the value of, say example n is 4, 4C2, 4C2, 4C3, 4 like that, so on. In that case you should know this formula. We will do one problem. And r equals to 6 C2, which is nothing but, what is n factorial? N is 6 factorial by r is 2 factorial into n is again 6 minus 2 factorial, right? So this becomes what? 6 C2 equals to what? 6 factorial nothing but 6, 5, 4, 3, 2 into 1 divided by, this is 2 factorial, 2 into 1, right, into 6 minus 2 is 4 factorial, that is 4 into 3 into 2 into 1. So I can cancel this, 4 3 2, 4 3 2 cancel. So 2 1s are 2, 3 is are 3 5s are 15, that is equals to 15. Therefore 6 C2 equals to 15. This is a value of 6 C2 using this formula. So know your formula very well, because we have to solve such problems using this formula. Without this you cannot proceed, and without this formula you cannot proceed. So you should remember what all I teach you. That will help you a lot. There is no reason for you to see that I don't like maths, I am very weak in maths. No, I want to remove the word impossible from the dictionary. It is possible provided you apply yourself. Problem number 2, 9C3. I'll write this formula somewhere here and write, that is NCR equals to n factorial r factorial into n minus r factorial. This is a formula to calculate any values given to you using that. So here n equals 9, r equals, this is r, equals to 3. So now n is what? I will write here 9, then C3 equals to what? n factorial is 9 factorial divided by c is 3 factorial into n minus r, 9 minus r is 3 factorial. This becomes what? 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 3 into 2 into 1. This is 3 factorial multiplied by 9 minus 3 is 6 factorial, that is 6 into 5 into 4 into 3, 2 into 1. So now what happens here? We have 6, 5, 4, 3, 2, 1. 6, 5, 4, 3, 2, 1. So you can cancel this and cancel this straight away. I'll teach you a shortcut method also. First understand this. So here 3 3s are 2 4s are 3 4s are 12. Therefore 9C3 equals to 12. So how is it is? Now what did you notice this? 6, 5, 4, 3, 2, 1. Don't you think this is 6 factorial? I can see 6, 5, 4, 3, 2, 1. This is also 6 factorial. So 6 factorial 6. What I can do here? I'll write this 9 into 8 into 7 into 6 factorial. I can stop at 6 factorial because 9 minus 3 is 6. 6 factorial 6 cancels. That is a shortcut. So we'll do one problem on that. So the answer is this. We are right. Oh, 7 is here. Sorry. So 3 for 12 into 7. So that becomes 12 into 7. 84. This becomes what? 84. 3 for the 12. 12 into 7. That is the answer. Now we will go for another problem. Now let us take this problem. 10 C 4. So what I'll do is I'll use a formula. So here n equals to 10, r equals to 4. Using that is 10 C 4 equals to what? 10 factorial. 10 factorial by 4 factorial into 10 minus 4 factorial, right? So you subtract this manually in your mind only. 10 minus 4 is 6 factorial. What I'll do here, numerator 10 factorial, that is 10 factorial is nothing but 10 into 9 into 8 into 7 into what we are left here, 6 factorial. What I'll do is I'll write 6 factorial, right? Because 10 minus 6 is 10 minus 4 is 6. That is nothing but 6 factorial. If you want, you can go on doing it, but again you get cancelled. So here, what I'll do? 4 factorial. 4, 3, 2 into 1 into 6 factorial. I did not have to write that. So 6 factorial, 6 factorial, straight away cancel it. Yes, sir? 2 4s are 8. So 8 and 8 cancels. 3 3s are. So this becomes 3 7s are 21. 21 into 10 is 210. That is 210. Therefore 10 C 4 equals to 210. This is a value of 10 C 4. So this NCR will help you to solve these problems. We will see its application using while we are doing problems on binomial expansion or theorem. 12C 8. So here n equals to 12, r equals to 8. Okay. So n is what? So that is 12C 8 equals to 12 factorial by 8 factorial into 12 minus 4 factorial. So 8 factorial, 12 minus 4. 12 minus 4 is again 8. So we'll do this is 12, 11, 10, 9, 8 factorial. Stop at 8 factorial because either this can be cancelled, this can be cancelled, no issues. So divided by what? 8 factorial, this becomes again 8 factorial, isn't it? So either you can cancel this or you can cancel this. So we'll cancel this. So this is what? 12 into 11 into 10 into 9 divided by what? 8 factorial 8, 7, 6, 5, 4, 3, 2, 1. Sorry, this is 8 factorial. This is 8. 12 minus 8. This is 4 factorial. Divided by 4 factorial. 8 is gone. This is 4 factorial. 4, 3, 2 into 1. See, by oversight we go wrong like this. Be careful in the examination. Don't be overconfident, because when sometimes we can also commit mistakes, likewise you also can commit. So be very, that's the reason we write this, because by oversight, with overconfidence, we go on. Even I was at the verge of committing mistake, because I should not get a fraction here. Immediately thought something is wrong. So try to analyze yourself and do this. So this is 12 minus 8 is 4 factorial. So 4 3s are 12, 2 1s are 2 5s are 5 9s are 45 into 11. So 45 into 11, 45, 45, 594, that is 495. So therefore 12C8 equals to 495. This is a value. 8C3. So here n equals 8, r equals to 3. So 8C3 equals to what? 8 factorial, 3 factorial, 8 minus 3 factorial. So what happens here? 8 factorial, 3 factorial, 8 minus 3 is 5 factorial into 5 factorial. So this is, I have to stop at 5 factorial. So 8, 7, 6 into 5 factorial. 5 cancels, easy for you. And this is 3, 2 into 1 into 5 factorial. So 5 factorial cancels. 3 2s are 6, 6 cancels. 7 8s are 56. Therefore 8C3 equals to 56. Got it? So supposing I had told you n should be positive and should be greater than r. What if I increase the value of r? R is more than 9. What happens here? You get a minus value. And if you get a minus value, you cannot solve the problem, because binomial theorem itself become false. That's the reason the value of n should be always greater or equal to r. 9C5, that is 9 factorial, 5 factorial, 9 minus 5 factorial. So here 9 minus 5 is 4 factorial. I will say this, 9 factorial divided by 5 factorial into 9 minus 5, 4 factorial. So what I will do, you can cancel any of this. So what I will do is, instead of stopping at 4, I will stop at 5. This is, I can write like this, 9, 8, 7, 6. The greatest among this is 5. I will stop at 5 value. 5 factorial divided by 5 factorial into 4 into 3 into 2 into 1. Okay. So this 5 cancels. So 2 4s are 8. 8 cancels and this cancels. 3 2s are. Okay. So what happens? 9 7s are 63 into 2. 6 126. So therefore 9C5 equals to 126. So dear students, I hope I have made myself very clear to you, and you have followed what is binomial expansion and its formula. It will be easy for you. Try to practice this and try to solve more problems on this, so that you become very good in this, strong in this, so that we will apply these things while calculating problems on binomial theorem.